Hello students, today I am going to start vectors, okay, and this chapter comes under AIHL 3.12 or AIHL 3.10. Both have the same syllabus. So it has concept of vectors, position vector, displacement vector, representation of a vector using directed line segment. So you already know about it, I hope. Base vector I, j and k, they are the base unit vectors, and component of a vector in terms of x and y or I and j, and then algebraic and geometric approach to the following: sum and difference of two vectors, zero vector, okay, negative of a vector, multiplication by a scalar which is k into v, and parallel vectors, okay. But look here, now onwards I am going to upload only half an hour session so that I can have more sessions in the week, half hour session, maybe 4 sessions I am going to take. So let us start. Yeah, vectors is an important chapter because on this 3-dimensional geometry is based. So many things in the 3-dimensional geometry, you know that the equation of a plane, equation of a line can be given in terms of vector form of the equation of a line, vector form of equation of a plane, okay. So I hope you will concentrate on this. Yeah, okay, then let us start. Directed line segment. The first thing is directed line segment. Look here, what is a directed line segment? Any line segment, you already know, A to B, it is a line segment. AB is a line segment, right? So AB is a line segment. Now if I put direction with it, suppose the size of this AB is given by 5 centimeter, I suppose, okay. Now if I say it is in a particular direction, because unless I define a direction, I cannot call it a directed line segment. If I call it only AB, so AB can be A to B 5 centimeter or B to A 5 centimeter, isn't it? Yeah. So suppose I define it from A to B. Now this AB line segment will become a directed line segment, and I will have to put AB and arrow over it. So this is the sign convention. If you write with 2 letters, you have to write capital letters, and if you have to write one single letter, then in the book it is given as a bold letter, okay. But here I am going to use single letter, small letter it should be, single letter, and with an arrow over it, because while we write, we cannot write bold and not bold, okay. So the same vector can be vector A also, small a, remember that I am writing small a, okay. Now if I have another vector, okay, CD, whose length is also same as AB, 5 centimeter, okay. So I will call it CD, right, vector CD, and this vector CD, though it has the same size, I cannot call vector AB equal to vector CD, because the second vector is totally in a different direction. It is in this direction, whereas vector AB is in this direction, right? So be careful, we cannot call same size vector as equal vectors unless they are in the same direction, isn't it? So direction is very important here. So to define any directed line segment, what we need? We need 2 things. To define a directed line segment, we need 2 information, right? The first thing is size of it. The second information required is direction of it. Now if you talk about the direction, then we can have direction in coordinate system also. Okay, so suppose this is x and y axis. Okay, yeah, this is x axis, origin y axis. Then I may define a vector, okay, OP. Okay, suppose 3 centimeter its size. Then because it is in a particular direction, so I can define it with the angle also, some angle theta, right? Now it will have some x coordinate and some y coordinate definitely, right? Okay, so we'll come to that in the next part, x and y. So this height will be y and the length will be x, horizontal length will be x. Okay, so this is the directed line segment. So OP is also a directed line segment. So like that you can have any directed line segment. So what you need for directed line segment? Remember that you need two information. First is the size of that vector. Second is the direction of it. Okay, then only we call it directed line segment. And such directed line segments are also called as vectors, isn't it? What is a vector? Vector is a directed line segment. Okay, so vector notation. Here we can have vector notation also. Okay, so as I already told you, vector notation can be AB or it can be OB or it can be OC, okay, and so on. So if I call it OA, let me draw an arrow diagram better. Yeah, so this is my vector OA. Okay, now this vector I can call it as OA, or I can also write it as small letter a, and arrow I will draw, because in the book you have bold letters, I already told you. Okay, so this is the vector OA. Now look here, this can be also a small letter and arrow with it. Now look here, if I write the modulus of this is called size of vector. Size of vector, or you can also call it magnitude of a vector. We will come to that when we will do component in the component form. When we will write the vectors, we will write their size also, so, or the magnitude. So suppose if this is of 4 centimeter length, then OA, magnitude of OA will be 4. Okay, so like this we represent it with the magnitude. Now what is O and what is A? O is called initial point where the vector starts, and P is called capital P, suppose here, or sorry, here it was A, is called terminal point, where it terminates, terminal point. Okay, so any vector will have always initial point and the terminal point. Initial point where it starts, so for example here O is initial point, terminal point where it ends. So here in this example, terminal point is A. Okay, terminal point. So I can also have some other vector. For example, if I draw a vector like this in this direction, PQ, so again P will be the initial point and Q will be the terminal point of the vector. Okay, so I hope you understood how to write vectors with the notation. It is a simple thing. Yeah, so let us move forward. Now equal vectors. Okay, two vectors are equal if they have the same size or if they have the same magnitude, isn't it? So two vectors are equal if they have same magnitude and same direction. Same direction, because direction is also important, only size is not important. So magnitude as well as the direction should be same. So let me draw two vectors here. Suppose this is one vector, I will copy it in another place. Now they are exactly having the same size and same direction. So suppose this is AB, vector AB, this is vector CD, starting at C, ending at D, and their size is 3 centimeter both of them. Then we can write vector AB is equal to vector CD. Okay. So whenever we write vector AB is equal to vector CD, then it means they have the same size and they have the same direction, same magnitude and same direction. Okay. Now look here, then there can be free vectors also, localized vectors and free vectors. Okay. If a vector, let me explain that first, then I will come to the negative of a vector. Free vector. So we call a vector free vector if a vector whose initial point can be taken anywhere, is not fixed, I mean. Okay, such a vector is called a free vector. Then there can be localized vectors also. Localized vector means where the initial point is fixed. For example, a force. In a force, the terminal point is fixed if you are pushing, and the initial point is fixed if you are pulling it, isn't it? If you pull a car by a rope, then the point where it is tied with to the car, that point is the initial point, and the force applied in the direction will be that vector. Okay. So that cannot be a free vector, isn't it? You have to tie up the rope somewhere to the car. So such a vector is not a free vector. Okay. Okay, then negative of a vector. A vector is called negative of a given vector if it has same size but exactly opposite direction. Okay. So same size and opposite direction, a vector having same magnitude but opposite direction. Such a vector is called negative of a vector. So suppose I have a vector here, vector A, okay, and if I draw another vector whose size is same but it is exactly in the opposite direction, let me draw same size. Yeah, suppose this is, or let me delete it, I will take this and then I will change its direction, exactly opposite direction. Yeah, so such a vector is still not same. Yeah, now their direction is same. Suppose this is a vector B, both have the same magnitude. So then vector B is negative of vector A. So I hope you understood. In this, magnitude of A is same as magnitude of B. Please remember it. Okay, their magnitude is same, but only the direction is exactly opposite. Okay. And they are parallel to each other also, but the direction is opposite. Okay, then let us move. Yeah, vector addition. How to add vectors? Okay, so to add vectors you have to follow certain rules, right? So for vector addition, you must take two vectors, and look here, let me draw two vectors. I will take one vector like this, suppose, yeah, this is my one vector, vector A, and there is another vector B, suppose I have it here. Okay, this is vector B. Now to add vector A and vector B, what I have to do? I have to where one ends, the second should start there, isn't it? Yeah. So therefore, I have to draw that vector B here. So the vector B will be something like this. Yeah, exactly same size and same direction I should take. So this is the vector B. Now when we add them, so their addition will be represented by the third side of the triangle, and this will be A plus B. Okay. So to add two vectors, what you need? The terminal point of one vector should be the initial point of the second vector. This looks like at 90 degrees, but then may not be at 90 degrees. I'll take the other two vectors. So suppose I have a vector P here, and I have a vector Q here. Okay, like this. Now what I will do? I will draw the vector Q where P is ending. So look here. Yeah, this is vector Q, not this one exactly. It was, yeah, let me erase that. Yeah, now it is correct. This is vector Q. And now when I will join from here to here, this will give me P plus Q, vector P, vector Q. I have to write arrow over it. Okay, vector P plus vector Q. So I hope you understood. Actually, this is also called as triangle law of addition, because when two sides of a triangle represents two different vectors in sequence, then the third side where the first vector had the initial point, the same point will be the initial point of the third vector, and the terminal point of the third vector should be same as the terminal point of the second vector. So look here, this is the initial point of P, and this is also the initial point of this vector P plus Q, and this is the terminal point of vector Q. This is also the terminal point of vector P plus Q. Okay, so like this I can write P plus Q, addition of two vectors. Is that clear to you? So where one vector ends, you have to draw second vector at that position, and like that you can add them, any number of vectors. Okay, look here, it is also can be any diagram. Suppose let me take one grid. Yeah, this grid I will copy on that page. Yeah, so look here, it is not that there should be only two vectors. I can have multiple vectors. So suppose vector P is this, or I will call them A. Vector A is this, vector B is this. Yeah, this is vector B, then this is vector C, yeah, this is vector C. Then A plus B plus C will be represented by this vector. This is A plus B plus C, vector A plus vector B plus vector C. Okay, so I hope you understood. So look here, where A ends, B starts, where B ends, C starts, and the final terminal point of C will be the terminal point of A plus B plus C, their addition, and the initial point of A will be the initial point of A plus B plus C. So I hope you understood this concept. Okay, So in any closed polygon can have one side as the addition of the other three sides, but there should be three sides, four sides, whatever number of sides you have, but they should be in the same sequence. What I mean, where one ends, the second vector starts, where second ends, the third starts, like that. Okay then. So let us see now zero vector. What is a zero vector? So a vector is a zero vector if its magnitude is 0, because direction cannot be 0. Direction will be somewhere. So a vector whose magnitude is 0 okay, such a vector is called a zero vector, and it is represented by O like thing, O and this arrow over it, so zero vector. Now what is the property of a zero vector? Its property is when you add a zero vector to any vector, there will be no difference, like simple numbers, okay, 2 plus 0 is 2, like that. Vector A plus zero vector is equal to vector A only. Or you can also write 0 vector plus vector A, okay, is same as vector A, okay. Now vector subtraction. Now subtraction of vector, you cannot call it just minus it, but if A and B are two vectors, then adding vector A to negative of vector B, to negative of vector B is their subtraction, okay. So how we are going to write it? A plus of negative of B. This will be called as their subtraction. Now if you add a vector to its own negative of it, then it will give you a zero vector. So vector A plus of minus A, vector A, will give you a zero vector, okay, like simple numbers. So when a vector is added to its own negative vector, the resultant will be a zero vector. Resultant means the addition. Addition of a number of vectors is called their resultant, okay. Now next part, vector equation. Now how can you write the vector equation, okay? So after we have seen addition and subtraction, you can have vector equation. Again, vector equation can be given by a closed polygon or a triangle or any shape. So look here, let, okay, I will take three sides of a triangle. So A, B, C, okay. So let A, B, and suppose I will write here R. So let AB is equal to vector A, BC is equal to vector B, and AC is equal to vector R. Then I can write vector R is equal to vector A plus vector B, which is nothing but addition of the two vectors, isn't it? So like this we can represent a equation of vectors, okay. We can write equation in terms of vectors. So what is that? It is nothing but addition of different vectors, okay. In the same way, let me take another shape. Suppose I have this shape, okay. Suppose this side is vector P, this is vector Q, okay. Let me put arrow also with it, and vector R, and suppose this is vector S. So therefore I can write in this closed polygon, vector S is equal to vector P plus vector Q plus vector R, okay. So this is also a vector equation, right? Yeah. So in this way you can write vector equations. So vector equations are nothing but addition of vectors, okay, or one vector is resultant of the different 3-4 vectors, okay. It is not necessary that they should be only positive, there can be some negative vector also. So suppose, let me show you one more example, okay. Suppose here is vector A, here is vector B, and here in the opposite direction I will take vector C, and this will be vector D, okay. Now here I can write vector D is equal to vector A plus vector B minus vector C, because I am taking negative of this vector, then only I can add them, isn't it? So where A ends, B starts, where B ends, C is not starting. So C is exactly in the opposite direction. So C is starting here. So what I will do, I will take negative of vector C, and then they will be in order. So vector A, vector B, and negative of vector C will be like this, and that will give me vector D, okay. So I hope you understood this. Okay, now scalar multiple. Look here, suppose I have a vector here, okay, vector A, whose size is 2 centimeter, let me call it, okay. Now there is another vector, now let me draw another vector exactly in the same direction, but its length is 10 centimeter. Its magnitude is 10 centimeter. Now I can represent this vector B, suppose this is vector B, I can represent vector B in terms of vector A, okay. So I can write, let magnitude of vector A is 2, magnitude of vector B is 10, and vector A and vector B have same direction, okay. Then I can write vector B is equal to 5 times vector A. So look here, I have written one vector as a scalar multiple of another vector. What is the scalar? Scalar is 5, okay. 5 is an scalar. So in general I can write vector B is equal to m times vector A, and this is called scalar multiple of a vector, okay. So B is scalar multiple of A. Now when B is scalar multiple of A, remember that both should have the same direction, okay. Their magnitude is different. One vector has some times another the magnitude of another vector, then only I can represent them as a scalar multiple, right? Okay. Next thing is, let us solve this question, and as I said, only half an hour I am going to take. So there are 3 minutes, I think 3 or 4 minutes are there. So I will end it. Maybe tomorrow I will upload also another lesson, so that in short period you can learn fast, quickly, okay. That is my intention. Some people suggested me, some of my students, okay. So look at this example, ABCD is a square, its diagonal AC, let me draw the diagonal AC, yeah, and BD is in this direction, okay. This is vector BD, yeah, in this direction. So I have diagonals AC and BD intersect at M. Okay, they both intersect at M, right? Okay, so what I have to find? If AB is vector P, BC is vector Q, as they are mentioned, AB is P, BC is Q. Find in terms of P and Q CD. Okay, C to D. Now look here. From C to D, I have to find a vector. Now look here. They have already mentioned that ABCD is a square. You know that the opposite sides of a square are equal in length and parallel to each other. Okay. Now this vector CD will be equal to vector P, but in opposite direction. Okay. So therefore I can write here CD is equal to negative of P. So I hope you understood, because P is in the right direction whereas CD is in the left direction. Okay. Okay. Like that. Now B part says find vector AC. So look at AC. AC is this diagonal vector. Just now we have seen that by triangle law we can add two vectors and get the third side of the triangle. Okay. So it is nothing but vector P plus vector Q, isn't it? AB plus BC is equal to AC. So let me write here first. AC is equal to AB plus BC. And AB plus BC will give me vector P plus vector Q. Okay. So like this I will get that. C part says I have to find vector AM. Okay. Now vector AM. M is the midpoint of both of them. Okay. So here is point M. Let me label it as M. Yeah, this point is M. Now what I have to find? Vector AM. Now look here, vector AM will be this vector. It will be half of vector AC, isn't it? So vector AM is half of vector AC because it is in the same direction, but half of it because M is the midpoint. So I will write here half of P plus Q inside the bracket, or I can write half P plus half Q, whatever way you want to write. Now D part will be vector BM. Okay. For vector BM, where is BM? This is BM. So BM is half of BD, right? BM is half of BD. And what is BD? BD is vector B, BC plus vector CD, isn't it? So I will write half of BD. And half of BD, how can I write half of BD? It is equal to half of BC plus CD. Okay. Now BC I have already. BC is Q, and CD we found in B part. CD we found in A part. Here is CD. So minus P I will write instead of plus P, minus P. So therefore my final answer is half of Q minus P. Okay. This is the vector BM. Okay. Q minus P, half of Q minus P. Is that clear to you? How I got BM? BM is half of BD, and because of that I have added half with them. Okay. Now this is already 34 minutes. So let me solve one more question and then I will stop, because I have promised I will take a lesson of 30 minutes only. So let me take 5 more minutes anyway, no problem. Okay, look at this question. This is a hexagon. So PQRS is a regular hexagon. PQ is A. Okay, this is A. QR is B. This side is B. Okay. Yeah, PQ is A and QR is B. Find in terms of A and B vector PX. Look here. P2x, this I have to find. Okay, so P2x, how can I find that vector P2x? P2x is same as QR, because look here, in a regular hexagon this length is same as this length. Okay, so a part I can write as vector Px is same as vector QR, and QR is vector B. Okay, like this I will get the answer of Px. Okay, now B part. B part is vector PS I have to find. Where is PS? PS is whole of this vector. Now PS is double of vector B. Okay, so therefore I will write PS is equal to 2px, because px already we found just now. Here px is this, so I will write double of this. Okay, so 2 times of vector B. C part says I have to find qx. Okay, now qx, where is qx? Let us see. Qx is here. Okay, this vector I have to find. Now to find qx, we will take this triangle. In this triangle we already have a, and we already have this, but the direction may be different. Okay, so I will write qx as qp, or I can write in any way. I can use this triangle also. Okay, in this triangle also, any triangle I can use. So qx can be qr plus rx. Why I am taking qr? Because b already we have. So qr plus rx. Now qr is already b, vector b, and rx, look at rx. This size is same as this size, but only the direction is opposite. So we will write negative of a. So like that my final answer is b minus a, vector b minus vector a. Okay, now D part I have to find rs. Rs, where is rs? R to s, this vector I have to find. Okay, now look at rs. Rs is same as qx, isn't it? And qx we just now found. So therefore I will write rs is equal to qx, and qx is b minus a, and that's it. This is the end of this question, and also with this I will end this lesson. So even I enjoyed a short lesson, and I hope you will also enjoy a short lesson. Okay, so next things I will take tomorrow, don't worry about it. So with this I will end this lesson. I hope you enjoyed this vectors lesson. Okay, if you liked my lesson, then please like, share and subscribe my YouTube channel. So I am going to have regular lessons. I will complete full chapter, and then I will cover past paper questions also. So if you have any suggestion or request, you can contact me on my email ID, or you can contact me on my WhatsApp number. Okay, the PDF of this explanation file will be, its link will be there in the description. Okay, then.